Okay, so there's three rules of two risky asset portfolios. I'm on page 152 in the book, by the way. The first one is rule number one: the rate of return on a portfolio is a weighted average of returns on the component securities with the portfolio proportions as weights. So WB is the weight of my bonds, and RB is the return on my bonds, and this WS is the weight of my stocks, and the RS is the return on my stocks. So this is a weighted average, hence I'm using proportionality here for weighting, times the return, and I add all that together, I add my bonds and my stocks at that point. ERR, which is expected rate of return, is a weighted average of expected returns on components with portfolio proportions entered as weights. So I'm adding a component to this. Effectively, I'm taking this and I'm putting this E as my expectation, and then I'm multiplying that by my returns. So this is a weighted amount. This is a weighted amount of the bonds times the expected return times, and after I multiply those, I multiply by the rate of return of the bond. And then I add the weighted amount of stocks, like our one prior example we had was a 60-40 split. We had 60% stocks and 40% bonds. We had our expected returns times our return on stocks for the RS here. And the variance of that is kind of what we just looked at, where we take our weight of the bonds and then the variance of the bonds squared plus the weight of the stocks, the variance of the, or the covariance of the stock squared plus 2 times the weight of the bonds, covariance of bonds, weight of the stocks, covariance of stocks, times the variance of the bond and stocks to get our overall, the square version of our overall rate of return variance. The risk return trade-off investment opportunity is generally speaking, our risk return trade-off is the greater the risk, the greater the return. But we can mitigate some of that risk through product or through portfolio diversification and diversifying our portfolio. So there's a lot of available portfolio risk return combinations. So some people are more adverse to risk, some people aren't. Also, you usually see that when it comes to investment strategies, you'll see people usually more okay with risk if they're younger versus if they're older, just because the closer you are to retirement, the less risk you're usually willing to take. So then we have our mean variance criterion here. So investors desire portfolios that lie to the northwest in figure 6.3, which I don't think I have figure 6.3 up here. Figure 6.3. No, there it is, to the northwest in my figure 6.3. These portfolios with high expected returns and low volatility, that's the north part is the high expected returns and low volatility is the west part. These preferences means that we can compare portfolios with a mean variance criterion the following way. If portfolio A is said to be the dominant portfolio B, if investors prefer A over B, this will be the case if the higher mean return and lower variance or standard deviation. So we're looking for a higher mean return, so a higher average return for the portfolio, and we're looking for a lower variance, meaning it doesn't change very much, or it's steady, which usually means less risk. So here's an example of our portfolio weights. We got stocks and bonds, and our weight of our stocks is 1 minus the weight of our bonds, because we have, in this case, we're doing that because we have 100% of our portfolio in either bonds or stocks. And then we have our expected return, which is this column A3 times column B3, or plus column A times A3. So that would be 0.2 times 10, and then plus column B times B3. And that would give me my 4 number here. Let me go to the actual Excel to show that formula. Okay, so I've got 0.2 times 10 plus 1.2 times 5. And I continue the same thing going down. Negative 0.01 times 10, 1.1 times 5, and add it together. This gives me my expected return. So my expected return for the portfolio. And then I look over here for my standard deviation. So what I'm looking for in here, investment opportunity, is I'm looking for the highest expected return with the least amount of standard deviation in this case. So that should tell me about how much I want to weight or how much weight I want to put in bonds versus stocks. And this is that northwest side we were talking about a second ago. So this is obviously the area that we're looking to shoot for with our diversification. All right, so various correlation coefficients. So a correlation coefficient, I'm sorry, give me a second, I lost my place in my. Okay, so I'm looking for my correlation between my bonds and including weighting how much I'm buying in bonds and how much I'm buying in stocks. So effectively, I'm using my variance and rate of return here to find what my coefficient is for bonds and stocks. So on this slide here, you can see, and I'll go back to the Excel spreadsheet, that what I've done, or what they've done, this is not my spreadsheet, they've done is they've taken the square root of A9 times C5, so we're talking about negative 0.01 times my my variance of stocks squared, and I add 1 minus A9, which is my weight of stocks, to get my weight of bonds. By the way, if I'm subtracting out my weight in stocks, then that finds my weight in bonds. They are working off the assumption that you're only investing in stocks and bonds here, so that is kind of a presumption they make. And then I take that excuse me, times D5, which is my coefficient for bonds, squared, plus 2 times 1 minus my weight in stocks again to find my bonds, times C5, my my coefficient, my correlation coefficient for stocks, times D5, my correlation coefficient for bonds, and then times E8, which is 0.2. And 0.2 is something they put in there because historical experience says that is a realistic correlation coefficient between stocks and bonds. So that number, they did put it in there. Several of these came from our prior spreadsheets. That one they put in there because that is a historically accurate correlation coefficient between stocks and bonds. Okay, so the slope. Make sure I get this. The slope of CAL is the Sharpe ratio of risky portfolios. So CAL it stands for the capital allocation line, So we're talking about our allocation in this particular example between stocks and bonds. So optimal risky portfolio has the best combination of risky and safe assets from the portfolio. So calculating this optimal risk is actually really similar to what we just were talking about doing. We take our expected return on bonds minus our risk factors, okay? And then we have our expected return on stocks minus our risk factors, our coefficient of bonds, coefficient of stocks, our correlation coefficient of bonds and stocks, divided by expected return on bonds minus risk factors, expected return on stocks again minus risk factors, correlation of bonds, expected risk on bonds minus our risk factors. So as always, like I said earlier, when we're looking at the other spreadsheet, our weight of stocks is 1 minus our weight of bonds. So that's how I find my weight of bonds. My weight of stocks is everything else. So this is what we're looking for, our capital asset line. Okay, and so we've got a capital asset line minimum. And effectively what we're saying there is that should be the minimum amount of our bond purchases, okay, our stock purchases. Should be higher, and that should give us a balanced return. So right there in the middle would be the ideal situation where my expected return is 7.16, and so my standard deviation is 10.15, which is the lowest amount of deviation with the highest amount of expected return in our portfolio. So we have portfolio O, and then we have portfolio C. Portfolio C would be still along the line. It would be less risky, but it would also have less expected return. So really, we can invest technically in any portfolio on this line and be safe. The lower the standard deviation, the less the risk, and usually the lower the return. The higher the standard deviation, the higher the risk, and the higher the return. So portfolio composition, asset allocation. So we have T-bills, which is basically our risk-free element of our portfolio, and then we're trying to measure out how much and what percentage we should do of stocks and bonds. And according to what we just figured out, through this process from my portfolio O, I need 31.24% bonds and 23.76% stocks. And we found this based on the fact that my weighted bond funds, I need 56.8% of the remaining after the risk-free asset, 56.8% of the bonds, or would be bonds, and 43.2% would be stocks. Okay. Stop that video there and continue with the next one.